Hello, hello. Let's see if I can. Share. Oh, okay. Hello, everyone. Let me go ahead and post this link to let other people join if they want. Pick here. This. Quote. All right. Hello, everyone. Today we are going to go through the recent tutorial that I put out, interacting with Uniswap on a fork of ZKsync Era using Era test node and Foundry. What a mouthful. I put this together, talking to our head of protocol, kind of put me into this rabbit hole of diving deeper into using Foundry and also using our Era test node that's built for ZKsync Era, and just kind of poking around with it, testing out, and getting to know Cast better. And so this was the outcome of my project or my little experiment, and I just wanted to share this with other people. I learned a lot about Foundry. If you don't already know about Foundry, this is a great tool to have and to use and to get to know more about. And really thank you to the Cypher and Updraft courses for providing those details about Foundry and helping me dive deeper. So today I'm going to start from scratch. I'm going to also try to go through the tutorial bit by bit. I have two screens. I might be looking over here, but we'll work on things together. And also explain kind of some of my thinking and some of the stuff that I went through while making this tutorial. So we'll go ahead and get started. I'm going to start from scratch. Let me go ahead and pull up. So what we'll do, start off with, I'm going to share an entire screen. Probably going to be easier. Okay, so I'm going to move this over here. Sweet. So we're going to be working with this tutorial here. You can always find a lot of our great tutorials from the Matter Labs team and from the community inside of community code. This is going to be, you go to our docs, docs.zksync.io. It'll take you to the builds section, or really will take you to the main page. You'll go to community code, or you can go to code.zksync.io, and you'll find our featured tutorials here. And really right now, one of the most popular ones actually is the building a custom ZK chain, thanks to Sarah on our DevRel team. Wonderful one to check out. But you see a bunch of different ones on here, and this is the one that we'll be going through today. So what you'll learn, how to set up and fork a local ZKsync Era environment, how to use environment variables to streamline your workflow, how to check balances using Cast, how to deposit ETH for WETH and transfer WETH, and how to approve tokens and perform swaps in Uniswap using the swap router. The cool thing about this, so the unlock here, is being able to fork ZKsync Era mainnet and test a bunch of different things and do things without having to spend any real funds or interact with the real mainnet at all, which is a ton of fun. So we're going to go through with that. Let's go ahead and get started. So some prerequisites to make sure that you are set. One, having Foundry, and we're going to use vanilla Foundry, not the ZKsync version of Foundry. We're going to use Era test node, so you'll want to download that. It's an in-memory node to fork ZKsync Era, to debug, mainly a debugging tool. It's a fantastic tool. Shout out to our DevRel team, DevX team, who built this. And there's an installation guide if you need. Or if you haven't already installed it. And then some other small things that were just helpful for me. I think you could programmatically do some of this stuff too, but if you want to just have a quick ETH converter, um, just to go from way to ETH and whatnot and go back and forth, there's that for you, and same for Hex and so on and so forth. The other ones we'll get to later. So we'll go ahead and start with our environment. Let me open up a new. I just started using Cursor. I really like it so far. It's a lot of fun. So we'll start with that. Anybody who's been using Cursor at all or has anything else, let me know. Why don't we just, nope, open up a folder. No, I'm just going to create one first. Go to terminal. And I like to keep my stuff organized in a documents. I have a test folder, then I go by year, and then I go by month. I actually don't know if I have a month yet for 10. Oh, already exists. Cool. So we'll get into 10. All right, got some tests here already, but we'll go ahead and go with we'll make a directory or a file in here, and we'll just do the cast tutorial. Sweet. So I am going to open that up in Cursor just to have a better view than just using the terminal. And for those you can see, sometimes I wonder too what people's extensions are and whatnot. This one is a Pomodoro timer. I don't need this right now, so I'm going to go ahead and shut that out. Tenor GIF. What is this? I think like Notion calendar thing. Being able to see what gas prices are, VPN, some converter thing, and then this mute pod where you can use the clicking of your AirPod to mute instead of having to use like Google Meets mute and stuff, whatnot. Anyways, it's a cool one to have. Oh, whoops, I did not do this correctly. So I want to be in my full cast tutorial, just to be nice and clean here. I'll keep them both open. We'll see. This is my first one. It will be interesting. I don't expect to be perfect. So let's go ahead and get started. Can I hide this? Still learning. Well, I'll keep that for now. I guess. Oh, use the top right or press Command B. Today I learned. Excellent. So first we're going to set up our environment. What you need to make sure you have open is Docker, so that it can, the Era test node can run in one of the containers. So I'll open that up. I have that open separately. I just have Docker desktop. I'm going to go to Era. I guess that should be in the prerequisites. Era test node, because I already have it installed. I guess I should check if I have it installed. I do. Excellent. And here, what I'm going to do is start it up, but I'm going to do it in the debug mode. It's just, I think, nicer. That way, if we run into any issues, I can clearly see what needs to be worked on. Or at least have a better idea of what needs to be working on, what issue is coming up. So if you are ever running into, you're trying to deploy on ZKsync or trying to have a contract do something on ZKsync and you're not sure why, you can use the Era test node in the debug mode and actually rerun transactions, and then it will give you a full breakdown of gas, of all the stuff that's going on with the transaction to help you figure it out. So then here, I've got fork mainnet. Let's zoom in a little bit. That's what we want to do today. And it's going to fork mainnet, ZKsync Era mainnet, and it's going to give us some accounts already. So it'll give private key and account. So we'll have that already set up. Fantastic. I'm going to open up a new terminal window there. And now something that was like a really big aha moment for me in this process was setting up the environment variables. You know, with the terminal, you can't just easily copy paste things into the areas as you want to. You have to, you know, if you accidentally put a whole line, you're gonna have to backspace the whole thing. You put the wrong address, backspace the whole thing, or you know, you can go up and down and go to your previous entry. But I don't want to have to always do that. So setting up your environment variables is a great way to have these shortcuts. So we're going to create a .env. For those of you who might be newer, if you have a dot before the name of your file, it's actually going to be hidden on Mac. There's a shortcut that you can unhide things and see it, but it won't be listed. Like if you looked at your folder, it wouldn't show. So what we're going to do here is we're going to do a few things. First, what we're going to do is we're going to set this ETH RPC URL. And basically what we're doing is we're telling, this is getting set up for Foundry. And the way that Foundry works is that if you set up ETH RPC, ETH underscore RPC underscore URL, it's going to continue to use that one. And so you don't have to do cast and then do RPC URL each time. So again, I'm trying to do things that are going to make things faster. If you are doing the updraft courses, Patrick Collins always says, if you're a lazy developer, you're trying to do as little things as possible. And this is one of those things. So we want the RPC URL of the Era test node. And so I'm going to minimize this a little bit. So it's running at 127.0.0.1.8001. So we're going to go ahead. You could do the HTTP localhost with the port number, or I'm just going to TCP, put it all for our example today. We're going to set a private key so that I don't have to keep going back and copying and pasting a private key. And also, you know, maybe somebody thinking if they're looking over my shoulder that they're going to get one up on me and steal my private key, but mainly just so it's faster. So I'm going to just take account 0 here. So I'm going to grab this private key and copy, paste. Then next thing that we're going to set, you can set the gas limit if you want. I'm going to leave it because I didn't run into any issues before, but if you start running into where transactions not going through, you can't get something to work, then you can just up the gas limit and get, what do I have? I set it for 10 million. Typically will allow you to go through things. Cool thing about using these private keys is they already have Ether on them. Test, or the, you know, the fort mainnet, some test Ether. Then I'm going to put later we're going to interact with the WETH address or wrapped ETH address, and I'm going to go ahead and add that. If you wanted to, you can double check this. Oh, I already have it right here. Perfect. Wow, thinking ahead. Thank you, Sarah, for the edits on this to make this work. So double checking on the ZKsync Era Etherscan. This is wrapped ETH. Here's the correct address. So I'm going to copy that and paste that here. Another thing you can do is you can actually go to the tokens, top tokens, and find it here as well. You can do other things too, but it just made sense for me for this. So we've got that. And then I'm going to do address again, so I don't have to just keep putting the same address in. I'm going to call it Addy. That's what I've been calling it, but you can keep it here, whatever you want. And since I'm just going to be using the same, the private key for this address, I'm just going to use this address too. And for now, I guess we can go with the swap router. We're going to add that because we'll get to that later. I'm just going to call it router. and I am lazy and I don't want to have to write out swap router, but I wanted to make it clear in the tutorial of what you're doing here. Uniswap swap router, you can see here from the Uniswap docs, this is for Era, right? ZKsync. Yep, ZKsync mainnet, and then I can go to the swap router and get that address. We got that A3A. Is this the right one? Yeah, I think so. If not, we'll fix that. 8 or A8A3. Perfect. All right. Now I've got my .env set up. I'm going to save this. White dot is trying to tell me that I didn't save this. And now what I actually need to do is load the variables. So we do that with source.env. And now when I am running my system, or like running through these things, I can make sure to use the full capital. You do a $ in front and the full capital, and it will kind of substitute that out. So I can check that with echo. Let's do echo Addy, and this is how I know that my my variables have been loaded or are loaded. It's perfect. Now let's get into cast. First thing we're going to do is check the balances. So let's make sure that this is actually working. Test ETH on a fork of main balance. And again, in the tutorial, it's my here. I took the shortcut and I just did Addy. That's going to be this big number of ETH. And this is where it comes in handy to have this quick ETH converter. I'm sure there's a better way. So if there's a better way, just let me know. Maybe something in the terminal I can do. But yeah, this gives us this huge amount of ETH. Fantastic. Thank you very much. And what I can also do here is I can test out and see if this is actually reading from mainnet. So what I had done before is I checked my public address, my bxpana.eth, and I can have a shortcut for that. Let me just pull that up. There we go. And let's check. Perfect. This is telling me that I have 0.0182 ETH. Well, is that true? And I check. Again, this is mainnet, right? This is, I think I'd have to go full screen. There you go. So this is on mainnet. I check 0.182 ETH. So it is reading from exactly where I want it to. So that is working as expected. Excellent. And what we're going to do is go ahead and, again, for the test by getting some wrapped ETH. And we're going to do that with cast. And before you saw, I could do cast balance, and that is just going to read my my ether balance. So it's not going to give me anything else. If you see here, we had, I've got some other tokens in there too. So, but it's not going to show me that. But later we're going to get to how you can check for specific tokens. So I want to be able to wrap ETH. I need to send ETH to the wrapped ETH contract. And I'm calling the deposit for that. So I'm sending value, I'm sending ETH, and I'm calling the deposit function. So I'm going to do cast, and this is a send because I'm actually sending funds. And I'm going to do to the wrapped ETH address. So I'm going to put my variable instead, so I don't have to write out the whole address here. And then I'm going to do the deposit function and send the value of ETH. I'm going to do, what was this amount? I'm sure somebody hopefully will come tell me later and be like, oh, you could have just done this for the calculations. I just added another 0 to have 5 ether instead of 0.5. And then, so I've got my value, private key. Well, now I don't have to write that big old private key. Oh, I think I'm going to change something after this. So then I've got this private key, and I'm going to send. Hide this for now. So it is going through, and it should be working on this process. Take a look. Cool thing about the error test node is you can see the process of things. So it looks like it was success, unless this was a different transaction. The payer address 33A, perfect. But this is what I was talking about. Like, you can look at everything that's going on within that transaction and debug. So cool, should be good. And voila, it'll also give me some output here, letting me know block, hash, the block number, and everything that this would have happened at if this was on mainnet. But I can look down here and see the status is success. So that worked. I will check that, right? Always verify, don't trust. This is where we're going to use the call option of cast. So we're going to do cast call. This is where I'm just reading reading from a contract and not writing. Send for writing, call for reading. And again, I'm going to do the wrapped ETH variable. I'm going to do balance. I'm calling the read function balance of. It is going to require an address, and it's going to output a UNT 256, and I need to tell it which address I want it to be looking at, or reading from the wrapped ETH contract of how much wrapped ETH I have. Sweet. So I did 5 ETH deposited. It's telling me it's got this much, which, boom, exact same amount. So I have 5 wrapped ether here. One other thing that I don't know what it was, so I'm going to leave this for now. So now we can go to testing this out. This part is really just like, again, testing to see if you're actually on mainnet, and just a little bit of fun. So I'm going to cast, I'm sending, or this is writing to the contract. So I'm going to do cast send. I'm going to go to the interacting with the wrapped ETH contract, and the function I'll be using is transfer, and then going to need an address and an amount is what it wants. And I need to put a recipient address. So I'm going to do my public address again. I could make this into a variable, so I don't have to keep doing this, but I think this is the last time I'll use this one. And the amount to transfer. So this is going to be in way, right? So you can't just put 1. It's going to do one tiny little way. So I'm going to go here. I'm just going to transfer 1 ETH worth. Gave me my amount in way. Put that here. Oops. Let's get back to here. And then I need to put in my private key since I'm actually interacting with the contract. And here, private key. And again, I enter. So right now, what I've done is I've transferred 1 ETH or 1 wrapped ETH to my public address by interacting with the wrapped ETH contract. It was a success. Again, if you wanted to do a deep dive, you can come to the error test that's running and take a look here and better understand what was going on. And here, oh, nice, took 2 seconds, sweet. I'm going to check. Let's check that I actually have cast that amount in my public address on this fork of mainnet. So cast what was it? Balance of address output is going to be 256. And the address that it's going to be checking is going to be a shortcut for talked about that pain of having to get rid of a whole line. You can do Control W and just gets rid of the word that is in front of the cursor. So that's a really nice tip that I just recently worked on or learned. I'm going to check this address, and voila, my one wrapped ETH. If you wanted to, 1 to the E18, fantastic. That's exactly how many decimals, so that would be, boom, I get my 1. All right, sweet. Now, if you were like, wait, did I accidentally like use real wrapped ETH, real funds? We can check here. Or if you're thinking, oh, look, I found a new way to get around the system. I can check the block explorer. I do not have any wrapped ETH. That is not true. This is on the fork of Aramine. So pretty cool. So it exists on this fork here, but it does not exist in real life. So that's why we've got this error test node running with that fork. Now, I use cast call to verify the transfer. Perfect, we did that. Now, since wrapped ETH is a ERC20, we're going to have to set approvals of how much the swap router contract can use. Before I do this, I'm going to make a quick change. I don't want to keep writing out private key. I want to write PK, save the file, and I'm going to have to do source again. And now I can do echo, and it is reading off that new loaded environment or variable. So I got that changed. I need to set an approval for my wrapped ether. And so some people think like, I can just like use whatever, but what I'm basically saying is like, I'm telling I'm telling the wrapped ETH contract, hey, let this address spend my wrapped ETH on my behalf. And this is why we don't do infinite amounts for approvals. Hello, GM, sir. Welcome. It's interesting before being a little alone. Now I've got Porter here. Welcome, Porter. So bear with me. I'll get some feedback from you afterwards, what I can approve. So what I need to do here, cast, send. Again, I'm going to use the variable for the wrapped ETH contract, and I'm going to set the approval amount for what address. So my input is going to be which address is being approved, and then the amount, the amount that I am approving it to use. So if you've ever used Uniswap before, whenever you go to try to make a swap of an ERC20 and you get that, how much do you want to allow? And usually people just click and it's like some infinite amount. This allows you to actually like tell exactly the amount that you want. So we are going to let the swap router, did I say call it router? I just called it router. We're going to let the router and the amount of approval, let's just go with 1 ETH. I am going to be lazy and just grab or 1 wrapped ETH. So I'm going to grab the output that I had here because I know that is 1. That's the amount. Again, this is going to be in way, and private key, let's do PK. Perfect. And now I'm going to set that approval. Again, I've got status, success. If I want to poke and prod at some of the other stuff, I can. But for today, we're just going to say, all right, we've got that success. Again, you can go to your error test node, check it out. And I can see I've got that approved. Now, this is where you get to have a little bit more of the fun parts. You get to swap for an ERC20 token. Now, what we're going to do here is add to our environment or our .env file. I'm going to make an ERC21. With this, the same thing. You're going to go to the ZKsync error tokens list. Now, you can use the Etherscan version. I think this is going to be the Matter Labs. Nope. Oh, yep, the Matter Labs version of the Explorer. You can use either one. It doesn't matter as long as you just grab an ERC20 that's on the ZKsync era mainnet. I'm going to actually do the ZK token just because it sounds fun. And that's actually what I did when I was first doing this. So I'm going to stick with that. So I'm going to add that to my my .env file. And next I need to find the Uniswap pool and fee tier. So what I'm going to do is I'm going to visit the Uniswap pool explorer. Oh, hello frame. Meet you. And cool. I have that link to take you directly to the list of pools that are on ZKsync era. So I have here, I'm going to look, and just to make sure that there's enough liquidity, I'm going to go with the one with the most TVL. So that is going to be a 0.3% fee, and I'm doing ZK to ETH. With this, it doesn't actually do ETH, it's doing wrapped ETH, so I'm going to be fine using this. Can I click? Yep, I click here, and it's going to give me the address for where this pool is. So I can copy that, and actually, do I need that one? I don't remember. I did some different things, so we'll leave that there for now. Fee. Oh, I think when I do the swap, yeah, never mind. I don't need that pool contract. So I just needed the fee. The fee is actually going to tell you tell the swap router contract later, like which one I want to actually use. So I'm going to put the fee. The fee tier needs to be in this format. What format is that? I guess that's a great question. But one thing that you can do if you're not 100% sure is you can actually go to, nope, let me get back to that contract. I can look up that contract on the Block Explorer. I can go to contract. I'm going to read the contract. And this is where I can actually just get the UNT24 number of how to enter that into here. So I chose the one that had a 0.3%. I can just go to fee here. I could also cast call and get this information too. But I think for now that should be good. Yep, that's all I need. So we've set that. White dot, don't forget to save it. And of course, now that I've done this, I need to I'll wait for that. I'm not going to load them yet. Not that that you can overload, but I'm not going to load them yet. So let's just go take a look at this really quick, swapping, and understand like what we're doing here. When we are interacting with the Uniswap swap router contract, we are interacting with this function exact input single. And oh, interesting. I guess it's something else that I can change. So I'm going to go to the router contract, and I'm going to look at my contract. Thank goodness it's verified. So this is where I could learn more about it if I want to read anything from it. But I'm going to, when I write to this contract, exact input single. When I was going through this process, originally I was trying to interact directly with the ZK wrapped ETH pool. What I later found out is there's this piece, this square root price limit x96, and then there's the call, I think a data section afterwards. I never knew what it was supposed to be put in there, and later I found out that if you're going to, only smart contracts can actually interact directly with the pool. So as a user here, I have to interact with the exact input single. So that took me a little bit to figure out. So that's part of the reason why we're going directly here, is you only smart contracts can interact directly with the pool. And then this is going to explain a little bit more of the struct. So if you look deeper into the contract, which Why not? We're here. Exact input single. So let's go to the code. Exact input single. And that's going to take me to this function here. And it has, let me see. Where's that part? Is there more? Exact input single. Aha, the params. This is going to have my parameters, just basically telling me like the things that it needs input into it. So when you call this function, it's going to be asking for the parameters of the struct, I believe. Still learning, so bear with me. Any corrections are also welcome. It's going to be needing a little bit of call data and these other params. I guess I should learn a little bit more about this. But ultimately, I got this figured out with knowing that it is asking for the token in, token that you're swapping from, the token out, token you're swapping to, the fee tier that you're going to be using. So that's going to be that's how it'll figure out which pool to use. The recipient who's receiving the tokens that you swapped, and then the amount in is the input tokens to swap, right? How much I'm putting in to swap. And then the amount out is the minimum that I expect to get out. And this is where things got a little crazy. I actually really dove deep into this one before I realized that you don't actually need this. But if you want to set a price limit for the swap, there's this like whole crazy function of how to get that. It's quite interesting. I use ChatGPT to typically calculate it for me, and ChatGPT has been a huge help during this process. And I would say, as somebody who is learning through this process, through things, is like use ChatGPT. Don't think that like you shouldn't. It's really accelerated my learning and allowed me to constantly have somebody there to ask questions and better understand things. Is it always accurate? Not 100%, but it definitely helps lead me into the right direction. For example, like figuring out that you cannot, an EOA cannot interact directly with the pool contract, ChatGPT, 0.1 preview actually. So don't be afraid. It's super helpful. Use the tools that are available to you. So now that we know what it's going to be asking for us in the input, let's go ahead and set up the environment. So we have our ERC20. We have the fee tier. Now the amount in is the amount of wrapped ETH that we want to swap. So we had given approval for 1 wrapped ETH before. So I'm going to say I want that 1 wrapped ETH again. Oh, cool. There we go. 1 wrapped ETH. And then the amount out. So the amount out, you can do like, 1 ETH and try to see what the math is to get out what the current price of the ZK token is. But I ended up finding this Kraken convert tool, which was really helpful because I really didn't want to have to go through all that. Again, I'm a lazy developer in training. And so this one allowed me to just like kind of find what I was looking for and see, okay, if I do 1 ETH, it should be about like 18,000.21 ZK tokens. So I am going to take that. But again, this is going to be in way. So I need to convert this. Where is my converter? Basically, what I'm doing here, ZK token has 18 decimals. Ether has 18 decimals. So I can say, okay, if I can pretend that says ZK, I put in the amount of ZK, it'll output the number, the amount in way, or with the 18 digits. So I can do that. And what is this amount? Out. And I got that. And the square root price limit, I think it needs to be at least set. So I'm just going to set it to 0 so because we don't need it. And I don't want to have to write that out multiple times. Cool. So we've got that set, everything that we need to. And what we're going to do now is we're going to load the environment or our environment, the variables from the environment. Thank you. Let's check that. Echo, fee, echo, boom. We've got those loaded in, locked and loaded. Now, we're going to execute the swap command. This gets a little tricky. I use ChatGPT to better understand this. It has something to do with like all the other examples only have one set of parentheses, and it's has something to do with how this is a struct. So the exact input single params are a struct, and so you have that within parentheses again here. So that's why you have these like double parentheses. And what I'm going to do, interesting. Oh yeah, this is correct. Okay. So I'm going to be sending the tokens to the wrapped ETH. So I need to do cast send. I'm writing to the contract, this swap router contract. I named it router in my environment. So that's why I'm doing router here. And then I'm going to say, all right, exact input single is what I am looking for. It's going to be the address. Oh, wait. Do I have to do... Let's find out together. This has been just a minute since I've done this. I think, yeah, I still have to say, yeah, I got to put in. So first, like we said, token in. So the token in is going to be an address, the wrapped ETH. Then token out. So that's another address. Then it's going to be the fee amount, which we saw before was in unt 24. And then it's going to be the receiving address, I believe, right? Recipient, excellent. So another address. Then the amount in, is that what it is? Yeah, amount in. So that's going to be unt 256. Amount out, unt 256. And then the square root limit x96 is a unt 160. And we're just going to use 0 there, but we still have to say that it's going to be used there. So close my double parentheses. So I put an extra 0 there. And then now I need to tell it exactly what I'm going to do. So I do the parentheses again, and I forget exactly why. It has something to do with the struct setup. I guess this is going to be a learning opportunity for all of us. We can check that out later, or you can check that out later. I don't think I'll go through that in this tutorial, but I will afterwards, promise. So wrapped ETH is the address in, the token address in. The what I expect to get out is my ERC20, which is the ZK token. The fee is going to be the fee variable. I want it to go to my address. So I'm going to use the addy variable. The amount in, we already had that set up. So I just do amount in, and then I'm going to do amount. I named it amount out. I put amount out min on the tutorial, so keep an eye out for that. And then the square root, and honestly, it's probably easier to just put the 0. So I'm going to do that. Close that out. I don't have to send any value with this because the value is actually only ether, and I'm not sending any ether here. I'm sending wrapped ETH or interacting with the wrapped ETH the swap router. I'm not sending any value. I'm telling the swap router to swap these two things for me. I already gave it approval. I'm not sending anything. Getting out of that mindset of thinking physically send things. Perfect, the value is 0. And then my private key. And away we go. Let's see if that works. It should. While we wait, if anything goes wrong, check your .env file to see if it works. Ooh, too little received. Too little received. All right. So either something is set up or wrong there. You can check to make sure you have all the proper things. Then you can reload the variables to make sure that they're there, or test them with echo, or check the logs in the error test node. Well, we already know. Look at that. Unable to estimate the gas for the request. The transaction is most unlikely, unexecutable. Too little received. So, I mean, we already saw that here. Too little received. So what I'm going to do is, why don't I just change the amount here? Maybe there's some actual difference between what the Kraken converter is showing and what is the actual amount would be for it being out. So I just changed. There was a 1 here. I just changed it to a 0. We'll just keep playing around with things to see if we can make it work. Oh, too little received. Let's check this again. So I'm sending to the router, interacting with the exact input single. Address. Wrapped ETH 0-20. Address. Amount in. Yep. Amount out. Yeah. Oh no. This is good. I like doing the debugging live because I feel like it shows people that sometimes you'll run into issues. All right, let's just do this. We'll make the amount out less. Oh, I know what just happened. So part of that, reload your environment variables. Before I changed that environment variable and I saved it, but I didn't reload. So if I do echo amount out, it is still giving me the number that is too big. So I need to do source.env. Nice to see you here, Porter. Thanks for staying. So nice. What a nice guy. That's why you should build on ZKsync era, because of Porter. All right, let's try this again. Now I should have the, if we want to test this again, make sure I have the right amount. Perfect. Lower amount. And, too little received. Too little received. I can check cast call. No, I'm sending the right amount. Let's check here. Oops. Yeah, I'm sending 1. Wrapped ETH. Wrapped ETH in. 1,500. 18,000. Check this. Let's just change this to 18,000. Is that the right way to go? We're going to find out. That's the source. Check that. Yep. Okay. And our amount again. Fingers crossed. Aha! All right. Okay. So this is probably where, obviously, you wouldn't want to do this on actual mainnet and just like YOLO and mess around with numbers. I clearly got way less than I should have. This is where this square root price limit would also come in handy, making this like telling you exactly how much you want to get out of it and making sure that you don't get this like random spread. Exactly, YOLO. So more or less for the purposes of just showing that you can actually do some things on this fork mainnet and using Foundry and not having to actually spend any real funds. So here's some notes and tips that I learned through this process. Again, like I said, AI is going to be huge. It's super helpful for understanding this. Thank you, Porter. I appreciate that. It's great having you here. If you guys have any questions, let me know. I do have to get going, so I won't be able to get into the nitty gritty of this process, but maybe I'll tweet about it just to show that I'm actually learning, and I'll write up about it. Actually, let me just check really quick. See you, Porter. See you next time. And thanks everybody for stopping by. And if you watch this later, thanks for watching. And see you guys later. If you have any questions about building on ZKsync Era, reach out to our DevRel team. We're happy to answer any questions. You can find us on our GitHub for discussions. Okay. Thanks for putting me on blast, GitHub. You can open up a new discussion if you have any questions. You can see we have quite a few ZK stack questions that are coming up. Ooh, in-memory node. So error tests have always answered. Excellent. But this is a great spot to get more involved if you're a dev. We have post updates here. You can also follow us on Twitter and okay, no search. There's search at ZKsync devs. Boom, boom, and get the latest updates that you need. Cool, cool. Well, great chatting with y'all. Happy Friday, and I'll see you next time.